Let's go over combinations. So this is a way of finding out how many ways something can be done where order or place do not matter. So for example, if we want to form a committee or a group or a team, or of course a combination, and order doesn't matter, we're going to use this formula for figuring out. So just like for permutation where order didn't matter, permutation was NPR, combination is going to be NCR, which is n factorial divided by r factorial times n minus r factorial. So this seems pretty complicated, but you'll see it's not really that bad. So if we had 5c3, it's going to be 5 factorial on top, then 3 factorial, and then just the difference of these two, which is 2 factorial. So everything gets multiplied together. And this isn't that bad to do by hand either in this case, because 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. So we see that these all cancel out. 3, 2, 1. This 2 reduces with the 4 to give us 2. Then when we multiply, we end up with just 10 over 1, or 10. So let's look at another example like this. So let's say we have 8c3. This is 8 factorial over 3 factorial times the difference of these two, 5 factorial. So if we write this out, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 5 factorial, 5 times 4 times 3 times 2 times 1. And you can see that these are going to cancel out. Then we can reduce also the 2 and the 6, that becomes a 3. Then the 3 and the 3 becomes a 1. And we have 8 times 7, which is simply 56. And similar to permutations, we could use a calculator for this. So we want to do 8c3, so 8, go to math, probability. Now this time we're going to go to NCR, and then hit 3. And of course we get 56. So let's look at this example. There are 20 students in a class. 5 of them will be given class duties for the week. How many groups of 5 can be formed? So here order doesn't matter because there's not any distinguishing factors between or among the 5 different students chosen. There's just going to be a group of 5. So in this case we're going to do a combination. 20 C 5. So of course we're going to do 20 factorial over 5 factorial times 15 factorial. So we could of course do out this math. I'm just going to use the calculator and type in 20C5. So here we have 20 math probability, go down to C, 5, enter, 15,504. So obviously we don't want to make a tree diagram or make any other type of groups by hand and figure this out. It's much easier to use this formula. 15,504 different groups can be formed. Now just to make this a little bit more clear, so same question, except now there are 20 students. They're going to be picked for office, for class office. So let's say we have a president, a vice president, a secretary, a treasurer, and let's say judge, I don't know. But the important thing is that there are 5 distinct groups. or 5 distinct places. So it's not just a group of 5 different people, it's a group of 5 people and each one has a specific title. In this case, the order matters. So you're not just a group of 5, you are either the president, vice president, secretary, treasurer, or the judge. So in this case, we'd have to use a permutation. We'd have to do 20 P5, which would be 20 times 19 times 18 times 17 times 16, the first 5 numbers, and see what that comes out to. Which is going to be probably a lot bigger. Yeah, it's let's say a whole lot bigger, 1,860,000, and I'm going to redo this as 20. Use probability P 5, and we should get the same number, and we do. So 1,860,480. So there is a distinct difference between a combination and a permutation.